motion under gravity. You know the equations of motion. V is equal to u plus at, where v is the final velocity, u is the initial velocity, a is acceleration. Then s is equal to ut plus half at square, v square is equal to u square plus 2as. These are the equations of motion. Now, equations of motion under gravity. Acceleration due to gravity is acting in the downward direction. So, for convenience, positive y-axis is taken in the downward direction. Then, acceleration due to gravity is acting in the downward direction. So, g, since it is along the y-axis, you can write j cap. Then, ax, acceleration along the x-axis is 0, along z is 0, then ay is taken as a, that is g, acceleration due to gravity. So in this relation, instead of a, you can write a g. So this is the equation of motion under gravity, where g is the acceleration due to gravity. So v is equal to u plus gt. Instead of v is equal to u plus at, v is equal to u plus gt. Then since it is moving in the downward direction, instead of s, you can write y. For convenience, downward direction is taken as the positive y-axis. So y is equal to ut plus half gt square. Instead of this a, you write g. Then v square is equal to u square plus 2as. So now v square is equal to u square plus 2gy instead of s, y. Suppose the body is moving in the downward direction, v is equal to u plus gt. Then if you are dropping, initial velocity will be 0. When u is 0, then relation is v is equal to gt. If here a boy is dropping a ball or a stone, if he is throwing, initial velocity is not 0, so v is equal to u plus at. If he is dropping, initial velocity u will be 0. Then when u is 0, v is equal to gt. Similarly here, if the boy is dropping this ball, initial velocity is 0. Throwing, initial velocity is not 0, then y is equal to ut plus half gt square. If dropping, initial velocity is 0, then this term will be 0, so y is equal to half gt square. This relation, dropping, this initial velocity will be 0, so v square is equal to 2gy. Suppose a boy is throwing the ball in the upward direction, velocity will be going on decreasing, then instead of this plus, minus is needed. So v is equal to u minus gt. In the upward direction, velocity will be going on decreasing, so v is equal to u minus gt. This expression y is equal to ut minus half gt square, then v square is equal to u square minus 2gy. A boy is dropping a ball, iron ball and a feather from a height of 10 meters. Let us find the time taken by the bodies to reach the ground. For that we can use this expression. Boy is dropping the body from a height h. So instead of y, you can write h. Since he is dropping, initial velocity u is 0. So you will get h is equal to half gt square. From this you can write an expression for t. T square is 2h by g. So t will be square root of 2h by g. boy is dropping the ball from a height of 10 meters. So for h you write 10. Then acceleration due to gravity you take as 10. Then 10 will get cancelled. Then square root of 2 is 1.414 second. So in the absence of air, or if you neglect the air resistance, both iron ball and feather will reach the ground at the same time, 1.414 second. That will happen only in the absence of air, or if you neglect the air resistance. Now let us find the speed of iron ball and feather when they reach the ground. For that you can use this relation, v square is equal to u square plus 2gy for finding the speed. Since it's dropping, initial velocity is 0, so we can write v square is equal to 2g. Instead of y you can write h, because it's dropping from a height h. V square is 2gh, so v will be square root of 2gh. Now 2, acceleration due to gravity 10, height 10, then square root of 200. So here 10 into 10, 100, square root of 100 is 10, then square root of 2, 1.414. So if you multiply by 10, it is 14.14 meter per second. Both iron ball and feather will have the same speed when they reach the ground. A boy is dropping a ball into a well. Question is, can we find out the depth of the well? We can find the depth of the well using this relation, this equation. Since he is dropping, initial velocity u is 0 in this expression. Then instead of y, we can put d, that is depth. Initial velocity 0, so this term is 0. Then half into g into t square. To find the depth, you should know time. So at the time of dropping, you start a stopwatch. Then when the ball is hitting the bottom, you stop the stopwatch. So you can find out the time taken by the ball to reach the bottom. Now using this, you can get the depth. But in the measurement of depth, there will be error. To know about the error, use another method. Take a long rope and insert inside the well till the rope touches the bottom. Then measure the length of the rope. That is the correct depth. So error is correct depth minus the depth which you are getting from this method. So that is the error. Then relative error, d correct minus d, you have to divide by correct depth. That is the relative error. Then percentage error, you have to multiply by 100. When you multiply this by 100, you will get a percentage of relative error.